Hello friends, welcome back to Mathematics Made Easy tutorials. Today we'll be looking at techniques of differentiation. Techniques of differentiation and we are looking at first on the list, polynomial rule. Polynomial rule. If y equal to coefficient a of variable x raised to power n, coefficients could be negative or positive, and variable 2 a power n could be it's an integer, could be negative or positive, of course, and independent variable x. And it could be t, could be x, any variable at all. And if the case a function you are dealing with is a polynomial function of degree n, and if that is the case, to differentiate this function, rule says all you need to do multiply the power by the coefficient an, then reduce the coefficient by 1. You multiply the power and the coefficient together, then reduce the power by 1. An x, then n minus 1. Let's look at a case study. Assuming we have a function y equal to 7x cubed plus 4x squared, and I'm asked to differentiate that. Very easy. Applying the rule. The first part, you have pi is 3, the coefficient is 7, so 3 times 7 giving us 21. Then you reduce the power by 1, that is 3 minus 1 giving us 2. Then of course, the second part of it, we have 4x squared. This time your n is 2, while your a is 4. So multiplying the coefficient and the power 4 times 2 giving us 8, you reduce the power by 1, that is 2 minus 1, going to give us x. I think it's quite easy. Now the second rule says product rule. Product rule. Assuming you are dealing with two products, two functions multiplying together. That's products. In terms of u and v, u multiplied by v, or v multiplied by u. Of course, they are functions of the independent variable. This time we are looking at x, y equal to uv, while u and v depending on x. If that the case, the rule says don't disturb yourself, don't worry, very quiet. Easy. You can keep one as constant without touching it. You differentiate the second function, dv over dx, plus this time around, you do the reverse now. Keep v, which you have not touched before, which you have differentiated before. Now differentiate the one you kept constant earlier on. That is u dv over dx plus v du over dx. And look at a typical case. For example, assuming I'm dealing with a function y equal to cos x sin x, cos x sin x. Of course, my dy over dx will be keeping cos x constant, cos x, differentiating sin x, that will give us cos x. Now plus, we do the reverse now, we are keeping sin x constant, differentiating cos x, and that is giving us minus sin x. All right, then further simplification give us cos x times cos x is cos squared, and of course minus times plus is minus, then sin x times sin x is sin square x. Of course, that is its product rule. This is Mathematics Made Easy. Please subscribe to our channel, recommend to a friend. Now look at the third rule before us, quotient rule. What if I'm dealing with a case whereby I have a numerator, a fraction, a numerator and a denominator? What do I do? Very simple. The rule says y equal to u over v. Of course, u and v are depending on x. This time around, the independent variable we are dealing with x, but it could be t, it could be any of the letters, but we are dealing with x this time.